sunshine. I realize I am in sunshine. The skies are turning blue. Would you like to...
Welcome once again to another interview on Accept Truth with Joy. I'm really happy today to be here with Joe Jensen from UVU. Joe, thanks for being with me today.
It's good to be here. Thanks, Heath.
Yeah, thanks for being here. So what I want to do is, Joe is one of my friends actually here at the university. We've known each other for a long time. We were hired on the exact same day and year. So we started at the same time. We've kind of been in this cohort. He's in the physics department. I am in the biology department. But I want to get just a little bit of a background on you, Joe. Could you tell us a little bit about, like, you know, your history, where you're from, how your academic career,
Sure.
maybe a little bit about your church career as well?
Yeah, I'm an astronomer by training. I was interested in astronomy as a young kid, and as a teenager I had a telescope. I used to go out and look. I enjoyed working in the planetarium, kind of like this planetarium where we're setting this discussion here today. When I went to college, I had some good mentors when I was younger that they gave me some advice on where to go to college. I got to go to Caltech, where they have a really strong astronomy program, and I got my first taste of looking through some of the big professional telescopes while I was there, and working with some great astronomers. I went to the University of Hawaii in Manoa for my graduate work. Hawaii is famous for astronomy. On Mauna Kea and Haleakala in Hawaii, they have some of the highest, clearest, driest skies in anywhere where they have observatories. So it was a fantastic opportunity to get to see some really great observatories, great facilities, and start my career as a research astronomer, mostly in infrared imaging. My area of expertise is measuring the distances to galaxies, and the distances to galaxies are mostly used for understanding how the universe evolves, how it changes with time, how it started off small, dense, hot, and has expanded to be the universe that we observe today. And so those are the things I like to talk about: cosmology, observations of distant galaxies, and how the universe is changing with time. I've been a member of the Church of Jesus Christ of Latter-day Saints since I was my whole life, and that has always been part of my life. I served a mission in Peru when I was younger, and since then I've just served in whatever callings I've been asked to serve in various places in Hawaii, Arizona, Utah now, California, and now Utah. And we've lived here like you for about 12 years now, since we moved to UVU. So I enjoy teaching here and doing research with the Hubble Space Telescope. You don't have to go to space to get telescope data now. They just send it down to us, and so we can do some really groundbreaking research from right here from humble Orem.
Awesome. You're married. How many kids then do you have?
I'm married, and I have 5 children, 4 daughters and 1 son. The oldest is married and off living on her own. I have 2 other daughters that have gotten married or are getting married this summer. This is 2021. And I have 1 serving a mission in Panama right now, and 1 still at home, daughter at home.
Okay. Well, great. And you've been here at UVU now then 12 years, and you're currently serving as, or you're not, it's not serving.
Yeah.
You're the department chair. You're
department chair
of of the physics department, right?
Of physics.
And how long have you been doing that for?
Just this last year.
Okay.
Yeah, and I've been an astronomy professor before that.
What classes do you
Astronomy is typically part of physics departments, because most of what we do in astronomy is actually just an application of physics. I teach the introductory level astronomy classes in the planetarium here. Also teach some upper division astrophysics courses, and then other classes like modern physics. Modern physics meaning physics from the 20th century on, so relativity and quantum mechanics and things like that.
Awesome. Well, great. Thank you for that. And, you know, I kind of was looking at this scripture from Psalms 19:1, where it says, "The heavens declare the glory of God, and the firmament sheweth his handiwork." And I thought maybe that would be a good theme that we're looking at today as we talk. So I found this interesting that, I've looked on the topical guide on the church website. There's no entry for evolution. Seems like the church just does not want to touch that topic in any way. But there is an entry for astronomy. I'm sure that
there's a number of scriptures all about stars, references to stars in the heavens. It's true.
Yeah.
And just so you know, in astronomy we refer to evolution frequently, but we're usually talking about evolution of stars, evolution of galaxies. Basically, anything that changes with time can be referred to in terms of evolution. And so when I refer to evolution in my career, I'm usually talking about how stars change and how galaxies change. And how
so not natural selection evolution.
Not evolution of life forms on Earth. That's right. Yeah. But we like that term.
Yeah, well, it's a good term. It's a good descriptive term. So I want to start off with maybe just, there's been a lot of concern from people that I interact with in the church, just with time. Okay, and obviously astronomy and cosmology is what at the bedrock of what is time. Mm-hmm. Could you talk a little bit about, how old is the universe? How do we know this?
Yeah.
And then maybe we'll kind of bring that forward into time, and how do we sometimes get time wrong here on planet Earth, especially like how we got calendars wrong and things. So maybe we could talk a little bit about time.
At the deepest level, time for a physicist is just another dimension, another way of measuring things. You measure the distances between two objects, you can measure the time between two events. You've probably heard of Einstein and space-time. We refer to space and time as if it were the same thing. But that said, the nature of time is really deeply quite mysterious, and the way the universe changes with time is different than the way it behaves in space. And so the study of cosmology is the study of space and time, of everything. Cosmology means basically the study of everything in the universe. And so we're very interested in looking at how things in the universe change with time. And so there are several time scales that are really important, and two main epochs, if you will, or two main time periods of creation. And they often get confused. The first would be the creation of the universe itself. And I find that it's very profound that science has come to the conclusion, just within the last 100 years, that the universe is not infinite in its extent in space and time. It had a beginning. It had a moment of creation when everything that we can see within our observable universe initially came into being. Sometimes people refer to that as the Big Bang, and the Big Bang was initially a pejorative term for people who thought the universe was expanding and growing with time. The main confusions that people have about the Big Bang is that, first of all, it's somehow theoretical or hypothetical. The Big Bang theory is very well grounded in concrete observations that many people can make. Even you, Heath, could go out at night and you can observe the dark sky at night and witness the beginning of the universe. If the universe were infinite in its time extent, if it had been around forever and had an infinite number of stars in it, there literally would be no direction that you could look in the sky that would not eventually touch a star. And so the entire sky would be illuminated as brightly as daytime if the universe had not had a beginning 13.8 billion years ago. But as we look at the expansion of the universe, we can see that it must have had a beginning. The Big Bang is not controversial. The Big Bang just says that the universe started off small and hot, and then it got big and cool. It doesn't explain where the universe came from. It doesn't explain where energy and matter came from. It just says, if you start small and hot and you expand, you're going to cool off. And we can measure that really accurately. We can measure, going back in time, looking through telescopes, what the temperature was, what the density was at different times, and map that expansion. And once you know how fast it's expanding, then the mathematics is relatively straightforward. It's kind of the way I describe this to my students in classes. I say, okay, if you know that Salt Lake City is 30 miles away from Orem, roughly, and you're traveling 60 miles an hour, how long does it take to get there? you're supposed to say 30 minutes.
Yeah, 30 minutes.
30 minutes, right? Takes a half an hour. If you're going faster than that or slower than that, then you can easily figure out how long it takes to get there. So our job as astronomers is to measure how big the universe is. In other words, 30 miles across, right? It's bigger than that. And to measure how fast it's expanding. That'd be the 60 miles per hour. So you can just divide those two numbers to get the age of the universe. And when we measure that, the acceleration of the universe, the size of the universe, the speed of the universe, put those things together, we get an age of the universe of 13.8 billion years. So 13.8 billion years ago, the universe was so hot, so dense, that no light could travel through it. The universe was opaque and behaved like a star. Inside of that hot, dense universe, all the hydrogen and helium was formed that we see in the universe today. They were formed. Without that hot, dense phase, there wouldn't be any helium in the universe, and the hydrogen that we see in the universe would maybe not exist. So we can actually tell how hot the universe was for how long, going back to just seconds after the initial beginning, what we call the Big Bang. From there, stars form, galaxies form, the stars form heavier elements. All the elements in our body, except for the hydrogen, were formed inside stars that then grew over many, many billions of years later. The second period of what we would call creation took place when the Earth and the Sun formed. That did not happen at the beginning. That's not a direct result of the Big Bang. The Big Bang was 13.8 billion years ago, and we know that from the expansion rate and how fast the universe is accelerating and so forth. But the age of the universe we get from a very different way. The age of the universe we get from measuring the amounts of radioactive elements that are in rocks, both here and on the moon, or in asteroids and meteorites that have come from an asteroid belt. And from those radioactive elements, we can tell what the age of our sun is and the age of our Earth is, and that's 4.6 billion years. Now those are two really big numbers, 13.8 and 4.6. But 4.6 is a lot smaller than 13.8. So for about 2/3 of the history of the universe, there was no Earth. So Earth did not form from nothing. Earth was formed from existing materials, a lot of carbon, nitrogen, oxygen, silicon, and of course hydrogen and helium. Those elements had to form over billions of years in a universe that already existed. So sometimes people confuse the Big Bang with the creation of the Earth. Those were two different events that were separated by 9 billion years. So our time, the way we perceive time, really depends on the road marks or the signposts that we're looking at. The formation of life, of complex life and things on Earth was really just within the last few 100 million years. That was just a tiny, tiny fraction of the age of the whole Earth. The age of the whole Earth is only a tiny fraction, well, a third of the age of the whole universe. Mm-hmm. But without that 9 billion years of what we call cosmic evolution or stellar evolution taking place, there never would have been the elements for us to form out of. We would not exist because the elements in our bodies literally come from stars that have died.
Okay. Let me ask a question about creatio ex nihilo. Mm-hmm. What maybe you can say what that is, in general, mm-hmm. and then what approach did Joseph Smith and the Mormon Church have towards that, and how does that then fit into the story of what you've been talking about?
So this idea that something was created from nothing, perhaps, ex nihilo, I believe that's what that means in Latin, doesn't apply to the Earth. And I think Joseph Smith and others understood this very well, that when we talk about the Earth forming from organization of pre-existing matter that was disorganized, that's not Earth being created from nothing. That's Earth forming within a molecular cloud, what we call a molecular cloud, mostly made of hydrogen gas, but also including carbon, oxygen, nitrogen, silicon, and complex, actually many complex molecules from made out of hydrocarbons. Those cold molecular gases and dust would condense and coalesce. That's a complex process. People study that in great detail, but you basically start with with tiny, tiny dust grains that are the size of smoke particles, and ices can form on these cold things, and then they stick together because ice is kind of sticky, and then you form smaller things that eventually form baseball-sized things that eventually form house-sized things, and then they start to collect gases around them, and that increases the mass enough for them to form planets in these disks around stars. So I don't know how much of that, the details of that, somebody like Joseph Smith would have understood, but they did understand the fact that the Earth was created from pre-existing matter. If we go back to the previous discussion of the Big Bang, where did everything come from? It's important to remember that the Big Bang model for the universe does not answer that question. It's not designed to answer that question. It appears that everything began at a very hot, dense state that was, smaller than the microscopic particle in an atom. But did the energy and matter that came from that initial Big Bang, was it part of a pre-existing universe or a larger infinite universe? Those are entirely within the realm of possibility, and those are things that we talk about, but there's more of a philosophy of physics than observational physics, because we can't, by definition, observe anything that is outside of our universe. Our observable universe is defined by a horizon that we can't see beyond. But that doesn't mean that the universe necessarily began with a singularity, began from nothing. It's possible. The mathematics doesn't tell us, though, what happens when things go to infinity. So I tend to be a little more circumspect and say whether the universe came from another universe and then was allowed to expand from that, a multiverse or something like that, or whether it really did begin with a singularity where time itself began, it's unknown at the present time. But what we do know is that since that time, the universe has expanded uniformly. It appears to be the same in all directions. It has a temperature that can be measured. It has a size that can be measured. It has composition that can be measured. And we are making those measurements today.
So have you ever in your time, or as you've interacted with others, are there issues of Mormon doctrine that are hard to reconcile with this story of cosmology that you've described?
I don't think so. I certainly haven't felt any need to abandon any truth that I found through science to preserve my faith, or vice versa. But you do have to realize that the chronology as it was recorded in the Bible, particularly about the creation and what happened after, can't be thought of in terms of 24-hour days or even 1,000-year days. You need a much, much longer period of time to explain the composition of the universe, the size of the universe, and the creation of our solar system. So as long as you have this understanding that some of the things in the Bible need to be interpreted symbolically or not in necessarily literal terms, then there's no problem, because astronomy and cosmology explain where the universe came from and where the Earth came from. And I think those concepts are very much in line with what we learn from the scriptures. We have multiple accounts of the creation. You'll notice that the order of the creation days doesn't necessarily line up in the different accounts that we have. And for me, that's okay, because what that means is what we're looking at is a conceptual description of the creation rather than a timeline literal description of the creation of the Earth, the creation of life on the Earth, or the universe itself. You can think of the creation of light as being as part of the Big Bang, as long as you recognize there can be another 9 billion years before the Earth is formed and the ocean's formed, and that's
okay. So when you're reading the scriptures about creation, or you're sitting in a temple watching the temple movie, you're not trying to maybe piece together an exact description that's trying to tell you. You're letting a little bit of fluidity happen. I mean, describe to me, like, what's happening in your, because I do this with evolution, right, as I'm watching the temple video, but what do you do in terms of cosmology?
If you're looking at like those molecular clouds coalescing to form planets, that would have taken place 4.6 billion years ago. And then before life is capable of living on Earth, billions of years probably had to pass. I don't know exactly when the time frame is for, the oceans to have formed, for the composition of the oceans and the atmosphere to form such that life could exist. But it's clear that the formation of the Earth was closely tied to the formation of life. Life progresses on Earth. The conditions on Earth change as a result of that life on Earth. And so we can't think of all of this happening on one day and all of that happening on one day. There had to be more overlap between those things. And so I think of it as a way of understanding the creation conceptually rather than as a literal timeline.
Okay. Maybe you just spurred a question to me that we didn't talk about previously, but this idea of, okay, so we have life here, and many astronomers and people who think about this have put these numbers together of the possible other worlds that probably have conditions that could have produced life. Could you run through that, and then maybe let's talk about how does that relate to a Mormon view of this universe, and what is God's realm potentially? I don't know. Let's kind of go down that.
Let's go down that as far as we can,
Yeah.
because of course at some point we come up against the fact that we don't know.
We don't know, right?
These questions, but what we do know. Let's just get our scales right here.
Right.
The solar system is the sun and the planets that go around it, the comets and the dust and Jupiter and Saturn and Earth. Those are the planets of our solar system. There are many moons around the Jovian planets that have liquid water inside of them. They have conditions that would be possible for life to live. There's no evidence that there's life on any other planet in the solar system other than Earth. But the conditions are there. The elements are there. The temperatures, the liquid water, hydrocarbons, it's all there. There's a source of energy, there's a source of nutrients, there's a source of liquid water, and those are the things that we think are required for life to arise. So I'm not saying that there is life on those places in the solar system, but what we see is the conditions for life just in our solar system alone are common. And so as we look into the rest of the galaxy is something like 300 billion stars orbiting in a common gravitational field. So 300 billion stars, of those, many have planets. Everywhere we look, we find planets around stars. We can't see the planets in most of those cases, but we can see their gravitational influence. Mm-hmm. If you can see where a planet exists and how close it is to a star, you can infer its temperature. If you can tell how big the planet is by how much light it blocks going around the star, you can tell how big the planet is. From gravity, you tell its mass. From the amount of light that it has, emits, or blocks, you can tell how big it is. From the distance to the star, you can tell its temperature. So if you put those things together, you now know the density of the planet and its temperature. And then we can infer whether it's a gas giant planet, whether it's too hot for life, it's frozen solid, or it's likely to have conditions like we have here on Earth. We don't know if there's life that can exist in other conditions, but we know that it does exist, at least in one case, our planet. Mm-hmm. And so if we look at all the stars that have planets with those conditions, in our galaxy alone, they measure in the tens to hundreds of millions, hundreds of millions of planets in our galaxy. Now, our galaxy is just one of 100 billion galaxies within the observable horizon. So if you take 100 billion and multiply it by 100 million, that's something like a 1 with 21 zeros. That's the likely number of planets in the observable universe that could potentially have conditions conducive for life. We don't have any idea how common or rare life is, but most astronomers believe that out of a billion trillion worlds, life is going to exist on at least some of them. Now, the problem with finding that life is the light that comes from those planets is so weak or non-existent that we can't actually detect it. Mm. And signals, if you wanted to communicate with somebody, would take so long to get there that thousands or even millions of years would pass before you could get a reply. Well, that's not very conducive to a communication. So astronomy definitely backs up this idea that worlds without number have been created. If you want to call worlds without number, we try to put a number on it. That's what scientists do. They measure things. So I would say worlds without number means something like a 1 with 20 zeros on it, or 21 zeros on it. And that's a pretty big number. It's a number that doesn't have a name that I'm aware of. It probably does, but it's like a billion trillion, I think, worlds out there. So the question then for me is, have we seen aliens? Have aliens visited the Earth? That's obviously been in the news a little bit lately, with UFOs and things like that. My spiritual take on this is when I read Doctrine and Covenants, Pearl of Great Price, and I read Moses, and Moses talks about worlds without number have I created. It's very clear that Moses and Ether and others who have been shown all the inhabitants of the earth, they're only shown the earth, right? I think it even says that. I only show you the inhabitants of earth because you pertain to earth. And what that tells me is that there's something special about this community of people, us, that have been sent to this earth. We're a family, if you will. And we're not shown the people that live on other worlds. I suppose God could probably have shown Moses all the different worlds that were out there and all the people that lived on all those other worlds, and whether or not they have, green skin, or whether or not they have funny bumps on their heads like in Star Trek or Star Wars. It gets pretty silly pretty quickly when you start thinking about that. But the point is, we're only shown the people for Earth. So I don't believe that God has allowed us to communicate with races or people from other planets. It seems to be that there is a, if you want to call it a veil there between us and the other planets. And I think the nature of that veil is very simply distance and time. Mm-hmm. Light travels so slowly, it travels pretty fast for us, but in the cosmic perspective, light travels so slowly that we really cannot visit or communicate with people on other planets. And I think that was probably by God's design. He assigned us to this world, and we can fly around in our solar system, but the people in our solar system on Earth are our family. So I don't believe that we have been contacted by people from other planets. I don't believe that there are aliens flying around us that come from other planets.
So we don't know what God's realm is then in cosmology, but I mean,
I don't either.
I've speculated with some people that perhaps God is in charge, maybe a heavenly father and a heavenly mother, because assuming the Mormon view of things, there's other heavenly fathers and heavenly mothers out there supposedly, and we're going to become heavenly fathers and heavenly mothers at some point. So there has to be room, space for everyone. And I wonder, does it make sense maybe Heavenly Father and Heavenly Mother and all of their creations is like a galaxy? Would that be like a reasonable realm for deity, and then a different galaxy is a different set of or do you think that maybe Heavenly Father and Heavenly Mother's realm needs to be the entire universe? Could you speculate on that?
I love to speculate about that because I don't know any better than anybody else. But what I can tell you from the scientific perspective is the universe is really, really, really big. It's, in fact, some scholars, religious scholars, not necessarily LDS, but religious scholars have wondered, why such a waste of space if Earth was created just for people? Mm-hmm. Why did God waste all this other space? Yeah. So the galaxy itself could have 50 or 100 million planets like the Earth on it easily. There'd be room even for multiple gods, multiple heavenly fathers to live within one galaxy if you wanted to. Okay. On the other hand, he could be exterior to our universe. Right. If God is exterior to our universe and kind of looks down on our universe, then pretty much any size horizon would contain enough planets to be effectively worlds without number. But let me just caution you, I've been talking about the universe, the known universe within our horizon, the observable universe, as containing 100 billion galaxies. That horizon is not an edge. That horizon is a horizon. And if you were to travel somehow magically to that horizon point, you would have a different horizon. that would extend around you by the age of the universe as well. You would see a different 100 billion galaxies. And if you went the other direction, you'd see a different 100 billion galaxies. And the reality is we do not know if the universe is infinite in extent or finite, because we can only see within a horizon. And just like on Earth, Earth has a finite surface, right? You can go all the way around it. So the Earth's surface is finite, but if you just imagine the Earth within your horizon, you're only seeing a tiny fraction of the surface of the Earth.
Yeah.
Very tiny fraction. And the bigger the globe is, the tinier that fraction would be. So we're observing an observable universe that contains 100 billion galaxies, which is room for hundreds and hundreds of millions of planets full of people.
Yeah.
And our horizon may extend, the galaxies and the universe may extend even infinitely beyond that horizon, and we don't know.
Okay.
So bottom line is, I have no idea personally if God lives within the universe or is external to the universe somehow. But within the universe, even the part we see, there's so much space and so many planets and stars that there's no problem imagining anything.
Yeah. Okay, great. Well, so astronomy is a feature in many scriptures. And this is one where we could just go down a bunch of lists, but maybe let's first just generally, how do you think about, how do you reconcile these stories about astronomical events that are happening with our understanding of heavens in Scripture? And then we'll hit on a few. Okay?
Yeah, I think we talked a little bit about the creation and how astronomy really informs our understanding of how the creation of the earth took place, more specifically than the Scriptures contain. I think we have to remember that, especially the Old Testament, a lot of that is very poetic, and it wasn't necessarily intended to be interpreted literally in a lot of cases. There's references to constellations and things that are kind of fun to think about. Especially Revelation the Revelation of John in the New Testament has references to stars and dragons and women, and people have tried to connect that with things like Virgo or whatever. There's the Christmas star, things like that are fun to talk about. But some of the ones that are more difficult to understand are things like maybe the stopping of the sun in the sky for a couple of hours. Yeah, like the Earth stood
still or something like that.
Yeah, and that's difficult. Let's first of all say, if God wants to stop the Earth from rotating through some magical process that doesn't obey the laws of physics, that's okay. I don't know how that would happen. I, as a physicist, want to think about it in terms of the physical laws. And so if the Earth is rotating, and I tried to stop it from rotating at the equator, you're going roughly 1,000 miles an hour. So how quickly can you slow down from 1,000 miles an hour without getting hurt? Because if you stop the Earth instantly, we all go plowing into the wall at 1,000 miles an hour, right? We don't fly off the Earth. That's a common misconception. We would not fly off the Earth if it stopped rotating. We would just, like braking in a car, you would hit the walls going 1,000 miles an hour. So obviously that isn't going to work. So you'd have to slow the Earth down gradually until it stopped. And doing that would probably take, well, I think of an airplane, right? When you're descending in an airplane, how fast do you stop an airplane? It probably takes 10 or 15 minutes while it's slowing down gradually before you land, and then you've still got to slow down from 200 miles an hour or something to 0. So I would imagine that you'd want to slow down the Earth gradually and then speed it up gradually so that you didn't kill everyone in the process of doing it. But that said, there is no force or source of energy that we have any concept of that could actually do that to the Earth. It wouldn't cause the Earth to be destroyed. It wouldn't cause everyone to fly off the Earth if that were to happen. If the Earth were to stop rotating, we would still have the same weight that we have now. It's just things like weather would be all messed up, and the day and night cycle would obviously be very different.
But even once you go down that rabbit hole of God magically stopping the Earth, well, then He could also magically stop everyone from not hitting the wall.
Yeah.
I mean, if you're gonna invoke some supernatural explanation for what we're reading in the Scriptures, right, of this event that seems to be like an event that we understand with physical laws, then okay, fine. Then you've gone through some. It's just like with evolution. If you're going to say, well, he just magically made everything appear and made it look like it was evolution, well then fine, right? But that's not at least in my worldview, it doesn't seem like that's the best explanation to understand these scriptures.
And so what I was going to suggest is the best explanation, since we don't have a way that we can understand why a planet would stop and start. There is no physical mechanism for doing that. It seems more likely that this was something that happens in the scriptures frequently, by my reading anyway, where people perceive things differently. For example, a star cannot go and stand over a particular building. The stars are too far away for that to happen. For the wise men to have been guided to the exact building where Jesus as a young boy was living would have required something in the atmosphere like an angel that would have guided them to that place, not a physical star in the sky that we're used to.
It's kind of like a rainbow almost, right? Where it doesn't matter. As you get closer, the rainbow is always further away.
Yeah. So if God had wanted to make the sun appear to stand still in the sky for a period of time, I think it would be easier for that to happen as a local effect, something that the people right there perceived, because there are no records from the Chinese or from the Indians or from other places in the world where they observed the sun stand still for a couple of hours. That seemed to be local to that particular group of people. And so it could have been like a local atmospheric phenomenon. And the reason I bring this up is because this is also true of the Christmas star. A lot of the things we read about the Christmas star we assume, but the experience in different parts of the world was different at different times. And so it may have been that there was no star in Jerusalem. It was an angel that led the shepherds to the baby Jesus. If you read in that part, there is no mention of a star at that part at all. The wise men were guided by a star. That was probably an astrological thing. The people in the Americas saw something that lit up the sky as if it were daytime. That was probably something that just happened for those people because it was not recorded anywhere else in the world. So I personally don't think you have to have a global explanation for a lot of these things that we read about in the scriptures. It's much easier to imagine a miracle taking place for a particular group of people in a particular circumstance. In this case, could well have been one. It's also possible that that was kind of a metaphorical statement. There are many people that think that that particular reference in the scripture was poetic, in the sense like we might say, man, it seemed to last forever. We don't literally mean that that test seemed to last forever while we were taking it. It just means our perception of time while taking that test is that it seemed to drag on and on. Or when you're playing with your friends or family and it seems like the afternoon just flew by and all of a sudden time seemed to go faster. Our perception of time is often contextual. And so that's another possible interpretation of that scripture.
But clearly there are possible observations that are recorded in the scripture that maybe were literal, like the moon turning to blood, or the night turning, or the day turning into night, right? Like eclipses or stars falling from the sky, right? There are things that we know about that could easily have explained this, and that maybe were common enough that people saw them, but maybe not so common that it seemed out of the norm. Maybe.
Yeah, let's talk about those signs of the second coming for just a second. We talk about the moon turning to blood. I think everyone who's lived in the West has probably had the experience of seeing on a smoky day the sun set in the orange haze and even turn red before it sets. It's entirely possible to make the moon look red or the sun to be extinguished, not by actually making the sun go out or turning the moon literally into blood, but just by having a lot of smoke and haze in the atmosphere. And so that would be one way to interpret those scriptures, is that when that happens, there's going to be a lot of smoke in the atmosphere. The stars falling from the sky. The stars don't literally have to fall. All you have to have is a meteor shower that produces enough meteors that you're getting hundreds or even thousands of them within a minute or within an hour to have it appear that the stars are falling from the sky. So I think those are, again, things that can happen quite understandably through the laws of physics without violating any laws of physics that explain those particular prophecies. And, Other cases of timing differences or the sun standing still are probably things like eclipses or local phenomena that were interpreted or written about that way by the people that wrote about them.
Okay. So I mean, from you, what I'm kind of hearing is, we should trust the science that we know about, and we should read scriptures carefully, knowing that sometimes it's symbolic, sometimes it probably was a description of a natural event that occurred, albeit imperfect in the way that it's described, and we're looking at it kind of anachronistically, right, from our point of view compared to them. Okay.
I guess I should probably state my personal opinion about all of these things is that God does not deceive us. I believe that clearly the description of Satan as the father of lies, and that God always confirms truth, always provides truth. So if we see something in the form of an experiment or an observation or a fossil or the light from a distant supernova or the pattern of the expanding universe, if we see those things and observe them, I don't believe they were created intentionally to deceive us by God. And so if the universe appears to be 13.8 billion years old because of the expansion, it probably is. Now, it may be a little bit older or a little bit younger depending on how we've made those measurements, if we find out that we've, need to make better measurements. But generally speaking, I think that if we see something observationally or through experimentation or through our studies that makes sense, that those are probably true. Of course, there's always a chance that we've made mistakes somewhere and we need to tune those up. But when you start making measurements of the Big Bang and you realize the cosmic microwave background radiation we see comes from the hot Big Bang, we see helium and hydrogen in just the right ratio to be explained in a plasma fusion process, and we see the motions of the galaxies as space expands, and we measure its deceleration and its acceleration, and we measure the amount of all the different elements that form the planets. It all hangs together very, very well. There's nothing very speculative at all about the Big Bang as a model for an explanation of the origin of the universe. And it just like the evolution of life on Earth, there's so much different evidence that comes from different directions that when you put it together, it becomes a consistent story. And sometimes we use the word model, whether we're talking about the universe or some other physical principle or theory. But I like the term story too. It's a story that we construct to explain all the different pieces that come together. And the more pieces we have, the more complete the story. Just like if you have a jigsaw puzzle. You can start to get an idea of what the picture is with only 10% of the pieces. But the more pieces you get, the more it fills in the details, the more you see the complete picture. And the more difficult it is to imagine that it's something other than what that picture is. Mm-hmm. And that's the case for the Big Bang model of the universe. It's very well established. There are lots of things we don't understand that we need extensions to that model that are still speculative. But right now, the Big Bang is by far the best explanation for all the existence of the stars and the galaxies and planets and their ages.
Speaking of models, there's this idea that's been going around a little bit called the universal model, which was developed, I think, by this guy named Dean Sessions, a member of the church, who has been working on this book for years and years. In a different podcast, we talked a little bit about this. And I was reminded that in 2017, maybe you could talk about this, but there was a meeting that was held, and you were quoted in the Salt Lake Tribune as saying, "This is pseudoscience. It's people trying to make money on something that sounds scientific but has no basis in observational reality, for that matter." Could you talk about this meeting and what prompted that?
So there was at the time people that were having a conference, and they were promoting this, I use air quotes, universal model. It's not a scientific model at all. It's people who have tried to come up with an explanation for things as they see them, not based on reality, not based on science, not based on observations or experiments or anything like that. But they've created this, and pseudoscience is by definition something that sounds scientific but is not based on scientific thinking. And by scientific think, I mean it could be the scientific process that we learn in elementary school, hypothesis and experiment and revision. Science is an iterative process. But a scientist like me is not free to ignore evidence. I am committed to seeking the truth. And that truth, in a scientific context, requires that if I am a humble and honest scientist, that when the data matches the model, then that bolsters that idea. If the data doesn't match, then I have to revise or replace that model with something better. I can't take all the evidence and say I'm only going to pay attention to this little piece that I happen to like. That's not allowed. And so anytime when people criticize scientists or science in general, I'm saying, oh, well, they don't know what they're talking about because they keep changing their mind. Well, we keep doing experiments. We keep getting new data. We keep getting new information that forces us to change our models or revise our models to better match what our story, better match our story to better match reality. If we didn't, then we would disconnect ourselves from reality and we would become fantasy. And that's what happened with astrology several thousand years ago. Astrology and astronomy used to be similar or even the same thing. There was a cultural aspect to astronomy. We look at the stars, we keep track of the stars. It was very important for cultural celebrations, for religious ceremonies, for navigation, for agriculture. Lives depended on a knowledge of the times and the seasons as reflected in the stars. So it was natural that cultural was connected to that. But at some point they disconnected. The scientific study of astronomy became disconnected from the idea that somehow the planets and the stars affected your personality. That's what we call astrology. That's pseudoscience. People sell that. They make money off of this idea that is not scientific. And it requires, if you're going to believe in astrology, it requires you to ignore everything that disagrees and only pay attention to the stuff that agrees. And that's what astrology is. If you're talking about other forms of pseudoscience, this happens all the time with medical things. Someone will try to sell you something, some product or some substance that is not proven to cure you or not proven to help you, with the idea that you'll only pay attention when it helps and you'll ignore all the data that says it doesn't help. So that's pseudoscience. In the case of the universal model, the idea is, just in a nutshell, that the Earth was created with liquid water in its core instead of rock and metal, and then it just extrapolates to a whole bunch of other scientific sounding things that have no basis in reality. We know what the inside of the Earth is like. We know what its density is. We know what its composition is. We know what its temperature is, because we can simply measure sound waves travel through the Earth. When there's an earthquake or when there's an explosion of some kind, those vibrations travel through the Earth and they bend as they go through different substances. If the substance is solid, they travel in one way. If it's liquid, they'll travel in a different way, because solids and liquids behave differently in how waves travel through them. And so by looking at the vibrations of the whole surface of the Earth, when there's an earthquake or when there's an explosion, we can actually map out the core of the Earth that's solid, the metallic part that's liquid, the mantle of the Earth that is solid rock but flexible, and then the outer crust of the Earth. We know their densities and we know what their composition is. And there's no basis for thinking that the things that are being sold by the universal model people have any basis in reality. They assume lots of things that are not true about the nature of gravity, just basic things about the nature of physics. And then they extrapolate that forward into,
things about biology,
life science and biology and earth science and the ages of craters, and craters don't come from meteorites. Well, I tell you, craters do come from meteorites because you can find the metal in the bottom of them that comes from the asteroids, and we've been to the asteroids and we know what they're made out of, and it's pretty, you have to ignore a tremendous amount of scientific knowledge to.
And perhaps, maybe, I used to think that this, the number of people that perhaps are listening to these kind of these pseudoscience voices, or visiting these pseudoscience websites, or buying these pseudoscience books, I used to think that it was a relatively small percentage of both the LDS Church, but I also thought that of the population at large. In recent years, I've doubted that assumption, because it seems like there is a lot of anti-science rhetoric in the church. Have you seen the same thing over the last few years, or
yeah,
I don't know if you want to.
I've thought about that. I haven't seen a tremendous amount of anti-science rhetoric that has been directed at me, or that I've had, in my own personal Sunday school classes or whatever. But where I do find that it's most common are in areas that impact people's lives most directly, their personal lives. When I talk about the Big Bang or something, people may or may not think that that is consistent with their religion because of what they've heard. But I don't feel any hostility from them because I, obviously believe in the Big Bang, right? But where that changes is when you start talking about things like global warming, or talking about the COVID pandemic, things that actually affect their lives and actually have caused them to feel some discomfort with their behavior. Then there is a lot more resistance to science, I found, whether it's putting on a mask, or it's, driving less, or, using less fossil fuels, or whatever it happens to be that they perceive as being asked of them, if they accept the science of something like global warming, or, the reality of the COVID pandemic. When people have to change their behaviors, they become more resistant, and that resistance often translates into resistance against science. So I haven't seen it too much in the astronomy context, but since astronomy does touch on those things, things like global warming has to do with understanding of how our Earth works. And what I really like about astronomy and the study of the planets of the solar system is that you can learn about Mars and you can learn about Venus, and they're like these bookends, and we're in the middle, and we're talking about very tiny changes around the center, but we can see what happens when the Earth would go one way or the other, what would happen. And so astronomy can really inform our understanding of our own Earth. If anything, astronomy has taught me how special our Earth is, how unique it is for life, how well designed it is for life. And this gets into a theme I'd like to just touch on for viewers just for a minute. And that is how well designed our universe is for our life. There is this idea that the universe could have been any one of a number of ways, that the laws of physics could have behaved, the laws of, therefore, chemistry would have behaved differently. How would life work, Heath, if chemistry, if electrons and protons were half the distances? It would completely change everything we know about life if something basic changed, just like the charge of the proton, or the charge of the electron, or the mass of the proton relative to the mass of the electron. Very, very tiny things that we don't really understand why they are the way they are, but they are. And the fact that they are make it possible for life. It's like there's a whole bunch of knobs on the universe, and they're all tuned just the right numbers for us. Now, it's possible that we'll learn through more study that that's the only way the universe could be. But right now, scientists and physicists in particular don't think that's the case. We think that there could be really an infinite number of different kinds of universe, and we happen to live in the one that's ideal for life. And so that's just builds faith that if God did create this universe for life, he did it really well. He did it right. And so I don't feel any reason as a believer in God to reject science, because that is the tool that I believe he has used to create a universe that is so optimal for us. And I don't have to reject science with the idea that it's either science or religion.
That's awesome. Well, I really liked how you said that. Are there any other things that you'd like to touch on. We had a few other things written down, but that was a great place to end. I don't know if there's anything else you'd like to touch on that sometimes comes up with this issue of reconciling, science and religion, especially in relation to physics or astronomy.
Yeah, I hope people realize that science doesn't care if you believe in it or not. Science will behave the way the universe and nature will behave the way it's going to behave. If we ignore that, if we decide to reject that understanding, we're rejecting a gift from God. I think there's a reason why God has placed a medical doctor at our helm right during a pandemic. We've been told that things like vaccines are a blessing to us. It's a gift from God to have this understanding. We shouldn't feel threatened by the truth, ever. We shouldn't feel threatened by scientific knowledge. We understand it's imperfect. It's never going to be perfect. Scientists are not trying to prove things. They're trying to understand things better because it makes our lives better. Frankly, we know it makes our lives better. It saves lives in the health care area. It makes our lives easier in the technology area. It'll help our lives get better, even in spite of big challenges like global warming and pandemics. We can overcome these things much, much better than our ancestors did before. So I am really optimistic, and I think we should, accept this knowledge that we get in so many different ways as perhaps imperfect, but as a gift from God, because it will help our lives be better. And that's been my experience, and I know that's the experience of many, many people around us.
Oh, that is awesome. Well, I think that's a great place to end. I really appreciate you coming and spending some time with me and
thank you.
In this beautiful planetarium that we have here at UVU. And I know that this will be a really interesting interview that hopefully a lot of people can take some, really think about. I've recently had conversations with people who just are so negative against scientists, as if we're trying to fool people, and I just love the way you stated that there at the end, where we're just trying to understand and we're trying to make it a better world, and that it's a gift from God. I really liked how you said that. So anyway, thank you, Joe, for being with me today. I really appreciate it.
We'll see you around.
All right.
Sunshine with me. The doors are open, the skies are too. Sunshine is coming in for me and you. Sunshine.